Okay, so this is question C1 2023. ABC is the center line of the pathway. Okay, we've got a circular curve here, a portion of it. Q is the center of that, down there. Okay, the pathway has the following specs. A to C, all flat, at 50 meter altitude. C to D, rising, okay, to a level of 55 meters at D. So imagine C, D at 50 meters and D at 55 meters. Using side slopes 1:1.5 for the cuttings and 1:2 for the embankments. Okay, complete the earthworks necessary to accommodate the pathway on the northern side of the road. The south one has been done. So 1:1.5 for cuttings and 1 and 2 for embankments. Right now, check your scale. Scale is 1:1,000. Check your intervals between your numbers. All right, they're in 5. So 5 meters in real life equals 5 millimeters on our drawing. Okay, so you got to check your scale. Now, so for our cuttings, for every 1 unit we go up, we have to go out 1.5 units. So 5 millimeters up or 5 meters up will be 7.5 meters in real life. So on your sheet, 5 millimeters up will be 7.5 millimeters on your sheet. And for your embankment, 5 meters would be 10 meters out because it's 1 unit, 2 units. So 5 millimeters, 10 millimeters. Right, so we're going to start. So A to B, okay, is an embankment here. So A to B, over here we have an embankment. All right, so we're going to go perpendicular to the edge of the roadway, and we're going to go up in 10 millimeter intervals. Then we're going to draw lines parallel to the edge of the roadway. So the green are for embankments here. Green are for embankments. Now, we know the roadway is at 50 meters. So here's our first point in our embankment. Our next altitude line is at 45 meters, 40 meters, 35 meters, 30 meters. So 45, 40, 35, 30. So we can sketch in the embankment there. We're drawing our tadpole for going up the hill. Now, we've got a cut, okay, to do over here. And we've a little, we have a little cut on this side as well. We've got a cut on the circular one, and we've got a little cut on the straight sectional road. Now, so we're going up 7.5 for the cuts. Draw a line through Q perpendicular to the edge of the roadway. Now I'll go up 7.5 here. I'll draw a line parallel to the roadway there, and I have a marker at 55 meters there, and I'm going to do another one at 15, which is another 7.5, and I'm going to lightly mark that 60. I am not saying we'll use that later, we'll just have a little bit of construction here now, so join them together. Then we're going to do the marks of the center, or from our center point. So I'm going out in 7.5s, so at 50 there, at 55, 60, 65. So I'm going to get my compass here, put it on point O, I'm going to swing my arc, okay, for 55, 60, and 65. Now, so my 55 arc I have to bring down just a tad more. So there, it's my 55, my 60, a 65, 65, 60 again, okay, 55, 50. So I'm going to freehand sketch these in, and look, there's an intersection where you have E2. And your tadpole swimming up the hill. And there's a heavy line here between the intersection and to there. Now, so I've got the cut on the left of the circular curve done. I now have a little embankment, 50, 45, 40, 45 and 50. So I now have a little embankment to do. So I'm going to go up 10 and 10. So this is at an altitude of 45 and 40. So I'm going to get my compass, put my compass on Q, bring my nib to the 45. So I'll mark the 45s. There. And then I'll go up to the 40, mark the 40 again. Now I have a 50, and I actually have a little bit more of a cut now in a moment. So I can see just down here at an altitude of 55. So I have my 55 arc there. Just going to mark that there. Now, we can freehand sketch in some of the points. Tadpole always swimming up the hill. So that one there, and then that's the 55 for the cut, and then the 60 is right there that I'm going to do lightly. Okay, lightly for a while. I'll need to heavy it in later. Now C to D is a sloping road. Okay, with C being the lower point and D being the higher point. can see, okay, D at 55 and C at 50. Now, for a cut, the cone goes at the lower end of the road, and the distance vertically is applied into the formula for the cut of 1 to 1.5. The vertical distance of the cone is 5 meters, so the radius of the cone is 7.5 meters because of this formula here. Now we'll also have an embankment because some parts of the road, look, 45, 50 is an embankment, and the cuts are, sorry, for the 60 and the 55 over here where the road is lower. The embankment, the cone goes at the higher end of the road. Now the radius of the cone is found by subbing the height of 5 meters into the formula, it's the 2. So the radius in real life is 10 meters or 10 millimeters on our sheet. So we'll start with our embankment. So we put our cone up at the highest end of the road here. We're going to mark in a radius of 10. Now the altitude of that base is 50 meters. Now I'm going to join corner of the road here as a tangent to the circle. Now I'm going to mark perpendicular height along that. So I'm going to mark perpendicular heights along that. So this 10 is at 45 and 40. Now I can go parallel to the 50. So here's a 45 and a 45. Now a 40, to be fair, I don't see there. Won't need any more. I may need one, okay, at 55. Going inwards, right, is higher, and I'm only using this to get a construction point on the sketch. Now the 50s are here and here for the 50s, and then there's a 55 and the 55. So they're only constructions. So I'm going to freehand sketch them in nice and lightly. And now I'm going to have a cut and a cut here because this is the embankment. So the tadpole always swims up the hill. So the cut, you put the cone at the lower end of the road. You put the cone at the lower end of the road. So I'm going to get my compass, set it to radius 7.5. So I'm going to swing my arc at 7.5. Which one? Is that the right radius? Yeah. Yeah, it's a little bit inaccurate that I'll just fix. 7.5. Now, we're going to join our 55 as a tangent to the circle. So that's at altitude 55, the base. Center point is at 50. And we're going to go perpendicular to that. Marking up every 7.5. So that's at 60, 65, no need to do any more. So I'm going to draw in my 60 line. My 55 line there for a cut is there, and a 50 line there for a cut is there. Another 55 line here for a cut is right here. Okay, another 50 for getting an exact point is there now. So I have my 60 there. I'm ready to mark these in. So I'm going to mark these in now. Now, there we go. Where they cross the curves, I move them. Okay. So the tadpole always swims upwards. Now I've got a bit here on this side. Okay, so this is a cut again. So 55 contour here, and then the 60 contour is here, and then the 65 contour is here, and we can mark them in. Now we've part A done. Now part B, okay, is on a separate diagram. Now part B, okay, the question to just go over again, as I accidentally made a little mistake in the previous one. Okay, I suppose easy to mistake. I joined the points to the wrong position R1. So we've gotten on a separate diagram on the map, the elevation and plan of three support triangles are shown. P or Q are the support poles. The plan of the triangular canopy on the poles is given. Draw the elevation of it. Look the way to bring up P. So that's easy to bring up P. To bring up Q is fairly easy too. So just bring Q straight up. I get Q1. Now R is a little bit more tricky. Now to get R, I'm going to have to look at the support pole R in plan, right? I'm going to draw a line parallel to the XY line in plan from point R. I'm going to get my compass, put it on point R in plan. I'm going to rotate the base of the pole parallel to the XY line in plan, and I'm going to rotate the point on the triangular canopy R1 onto that line. So here's R1. Now the base of the line moves over on the XY line, so I'm going to join that up. Draw that up over, and this locates the position of R1 on the pole. So I'm going to join them together. So we have the points here together, and we're going to join them in elevation to get the elevation of the canopy P1, Q1, R1. Okay, now the next part of the question says determine the strike and dip of the canopy. The strike is a horizontal line on this surface P1, Q1, R1, so the canopy. So it's a horizontal line. Now, I'm going to label that 1, and I'm going to drop 1 down to plan view. It's on line R1, Q1, so it's there, number 1. Now, I'm going to join that back to P. Now, this is my strike in plan, and it's a true length. Now, if I look along this line, I'm going to produce an edge view of the triangular canopy, the pink surface P1, R1, Q1. And that's because if you look along the true length of the line, the surface it rests on will project as an edge because the line, a line on that surface is projecting as a point. Now this is used in intersecting surfaces, oblique planes. It's very common throughout the whole course. It's the same as the true inclination of a surface to the horizontal plane. Here's the HP in an auxiliary. I'm going to take the heights of Q. I'm going to mark it here. I'm going to take the heights of R1 and I'm going to take the heights of P1. You don't need to do P1, just 2 will do. Mark them on there, and we're going to connect them together, and they're going to project, all the 3 points are going to project as an edge view. Now the dip, okay, is here. So here's the dip, which I'll give you a numerical angle now in a moment. Numerical value is 28 degrees. Okay, so that's the question complete for part B. There was part A. Okay, as I said, made a little mistake there. I was originally doing my part B, so I'll start again that you've seen. Remember your tadpoles swim up the hill. So for a cut, they're away from the road. For an embankment, or towards the hill. There's a little CAD solution of the question. Fun time. Right, cheers, thank you, bye bye.